Good afternoon, Madam Chairman, ladies and gentlemen. John Martin, the name. I've been in the water industry for a lot longer than most people around here, I'm afraid. And I do actually remember dissolved air flotation coming to the fore itself in the 70s. But today I'm going to be talking about high-rate dissolved air flotation with a difference. And I'm going to be centred really on the ability to upgrade existing assets, which is the subject of this particular session. Before that, I want to talk a little bit about the company Processus, not known to many people around this room, I guess. Then the technology, the high-rate technology of dissolved air flotation, and how we actually achieve that. Next, how that relates to upgrading of existing assets, because that is important in today's climate within the UK. A few mentions of plant performance. We have carried out quite a lot of work in the northwest of England on a particular flashy river, and I've got some data taken from a data logger which will explain exactly what we achieved and how we achieved it. Last but one, a record of installations of the plants around the world. I haven't just generated a list of names and venues and capacities. I've tried to summarize that in terms of what's happened year by year and how we've managed to achieve those figures. And finally, I'll give you a list of benefits of dissolved air flotation, high rate, turbulent, over and above conventional dissolved air flotation. Firstly, the company. We're a UK registered company with an office very close to the northern end of the M6 toll road. We can actually see it from our offices, and we're part of a large Midlands-based engineering contractor that does fabrication both internally within the group and uses external local sources of fabrication. But Processus itself is an engineering-led, process-led engineering, procurement and construction contractor with a full turnkey responsibility and capability. We have an in-house, fully experienced project management team, which you will see later when coupled with the design experience of our principals, Richter, a Finnish company. You'll understand why that is important. And we operate in water, wastewater and industrial effluent markets throughout the UK via this exclusive arrangement we have with Richter, the Finnish principals. That arrangement actually covers quite a few European countries, with the exception of France and some USA countries as well. The technology. The fact that it's a high-rate technology, probably ought to explain what is meant by a high-rate technology. If you divide the total throughput of the plant by the surface area of the flotation unit, in other words, you've got meters cubed coming in, square meters of the flotation cell itself, you have a figure, when those are divided, approximately, well, up to 40 cubic meters per meter squared per hour. Probably doesn't mean too much to some people, but when you consider that the plants operating within the UK normally range from 10 to 15 meters cubed per meter squared per hour, you can see that our plant is considerably smaller than anybody else's currently available. As I said earlier, more than 50 reference plants, full scale, operating totally around the world. Like the gentleman before me, we are able to operate in the tertiary treatment of sewage as well as potable water. In the sewage field, then I don't think ours is as sensitive as MBR. In fact, I know it's not, but we can achieve very similar results. In fact, I'd like to do some comparisons one day with Ahmed to see who we think is the better technology. But to demonstrate this technology, we have a pilot plant. People that we've spoken to throughout the water industry are sceptical. Because of their history, they say 15 meters per hour per metre squared is the most you can achieve. Well, we had this pilot plant up in the northwest. Within 1 day, we were achieving 35 on a flashy incoming raw water without proper chemical control. The flow diagram. This you will probably recognise as a conventional dissolved air flotation plant with one notable exception. This plate across here is that major exception. In conventional dissolved air flotation, the treated water leaves in a direction as shown here. So you achieve adverse flow conditions across the whole of the flotation cell. Within turbulent dissolved air flotation, then we have a different arrangement. We have the whole of the flotation cell is covered by a false floor, which is perforated. And that allows the water to exit across the whole of that surface area, which is one of the clever things that we have over and above conventional. Just a couple of shots of full-scale installations, 2 taken from Finland, and a couple more. But one of the interesting things on the bottom right is the sludge withdrawal system. Because we're operating at that extremely high rate, the sludge withdrawal system can be simplified, and whereas the old system involved chains and scrapers, ours is a simple 6 inches in diameter, 150 millimeter diameter stainless steel tube with a helix of rubber sheet attached to it, pushing the sludge over the beach plate. And I'll explain how we actually achieve that. What I've done now is 2 drawings in section, one of a conventional dissolved air flotation plant, and another one, the same capacity of a high rate dissolved air flotation plant. The first thing you will notice on the high rate, the flotation cell is extremely short relative to the conventional one. The aspect ratio of the flotation cell itself is 1 length, that dimension is 1, where the width is 3. Now that is the totally reverse of the conventional plant. They would have, or conventional plants would have 3 lengths with 1 width. So that enables us to take sludge off intermittently using that conveyor left hand side of the bottom right picture. That means no complicated chain scrapers, no bang down of the solids when these things hit the water. This is ongoing, simple, and can be replaced totally, we think, within 4 hours using non-installed spares. I said earlier that I'd be talking about some real operating data which we obtained from actually the River Dee. I hope you can see that. I didn't change it because otherwise you'd accuse me of falsifying the numbers. But you can see that the river at one time had an incoming turbidity of 160 NTU. Bearing in mind this river is feeding into a tidal estuary and there is a weir. It's not saline and never is saline, but the backup does create a big surge when the tide goes out, and we're able to, we actually envisage those sort of turbidity spikes coming in, which after a time we could predict as being caused by the tide. In fact, we could predict when it was going to happen when we looked at the tidal timetable. But across that same period, 21st of March to the 30th of March, from our data logger, we had a turbidity of always less than 0.5 NTU. And if you remember, this was a simple chemical addition, one stage, PAC or aluminium sulfate, didn't matter which, no polymer, no proper pH control, and no chemical dosing relative to flow. So we're running very simply, and on a full-scale plant it wouldn't be that way, but we still demonstrate the performance of the plant within those simple means. As I said earlier again, the installation record, rather than just give you a list of names of locations, I've tried to concentrate or reduce that to simple statements. 10 years, 12 years now, since the first one was installed, and now there are more than 50 operating, some including in Saudi Arabia, on both wastewater and seawater, brackish water, as a pre-treatment to membrane treatment. Am I okay time-wise, Mr. Chairman? Yeah? Okay, thank you. So in summary then, I'd like to list the benefits of this process and how it applies to the upgrading of existing assets. If you remember, I talked a little bit about the ratio, aspect ratio of one system to another, and how it is important that they are roles reversed for reasons of sludge withdrawal. To make one existing plant into a high-rate plant is very simple. All you need to do is to install a steel or stainless steel wall a third of the way down the dissolved air flotation tank and install on supports from the ground, from the base of the tank, this perforated plate which enables the water to exit across the whole surface area. That is a simple exercise. The stainless steel or the steel wall doesn't need to be able to withstand total pressure, static head, because the plate joining the two is perforated. So it's a simple installation that can be done quite cheaply, and at the same time you get a much better output from the plant and a much better quality output. Normally, if it was a full-scale plant with proper chemical additions relative to flow and turbidity, we would expect to get 0.1 NTU continuously. On the sewage treatment side, well, it can operate completely without chemicals. We have some plants operating that only use chemicals when the flow rate of sewage coming in goes very high after flooding. In other words, you've got surface water contaminating the sewage and giving rise to high colloidal matter, which we cannot remove only with chemicals. The chemistry is quite simple there, nothing sophisticated. We would prefer always to operate without polyelectrolyte because it's important to us that the flocks formed are large in number but small in size. I haven't talked about the chemistry of the process because I don't have the time, but what we can do is to generate sludge somewhere between 2 and 4% dry solids. If we do happen to use a polyelectrolyte, it would be higher than that. But there is a trade-off between the ability to move this sludge and its volume. The developments have been made over 13 years. The first one was in 1999. It's simple to design as a design and build exercise, simple to upgrade in terms of existing plants, and overall totally cost effective. Just a couple of pictures of icons that you will recognize, or logos that you will recognize, that are currently clients of our group, and a few more. A lot of the water treatment companies you'll recognize, Anglia and Severn Trent and these people. We know them all. But more importantly, thank you for your interest and thank you for listening for me. Thank you.
Thank you, John. Well, we've heard two very different speakers. The success of Ahmed's MBR project and things to consider when looking at MBR technology. basically is to consider the location and the weather conditions. And as we're now officially in a heat wave today, that could be a very valid point. And also, you need to have the skilled personnel available as well. And then we've heard John talking about the success of the TDAF, where the benefits have included low sludge volumes, the simple design, and it can operate without primary coagulants. So I'm going to open it up to the floor. Do we have any questions for this gentleman? Oh, come on, don't be shy. Yes, there's one over there, oh, two over there. Can you state your name and company, please?
John Kilgallen, JK Environment. I'd like to ask about the MBR process. I assume that you used it to increase the capacity of your existing wastewater treatment plant. I'm wondering, what was the mixed sticker suspended solids concentration you had in the old sewage works? And do you know the maximum mixed sticker suspended solids you can now work with after the installation of the membranes?
Yeah, I'll take the first question, which is about we increase the capacity of the wastewater treatment plant. Actually, the MBR was sized for that capacity. We had sized that plant considering 3 trains. Each train will take 50%. So we have 1 train that we can consider as a standby. Okay. The mixed liquor suspended solids was designed, you know, as like any MBR. When the vendors what they're saying, you can go from 8,000 as minimum, and you can go up to 12,000 ppm. So that's the mixed liquor. Yeah. The good thing with this plant is we had this additional train actually. In case we have any problem, we can still run the plant with 2 trains with the 100% capacity.
Thank you.
Well, yes, it's a question to Ahmed. Kevin Mackay from Wetox Limited. I was very interested to hear that you, when you upgraded, you took out your sludge drying beds, as I understand it. What did you do with the sludge afterwards then, if you take them out?
Actually, in this area, we have a landfill area which is dedicated for sludge disposal. So we have an area which is fenced and have monitoring wells also that we can take the which is dried sludge and dispose there. Yeah.
Hi, Mr. Ahmed. According to your project, actually, I am from that region. I'm from Saudi Arabia. So I know there is a lot of kind of material that has been done with a special one. When you're using the pipe, there is a kind of pipe that can be around PVC. We can use it, which is resistant to the hot weather. Also for the concrete, you can use something which can be mixture with the concrete to be isolated from the hot weather. This is for the first question.
Yes, regarding piping, actually, again, PVC, it's not our recommendation. We have a standard in our company also that PVC should not be used under sun. It should not be used outdoor. You can use PVC when it is buried underground, but if you want to use PVC, use CPVC. Okay, CPVC is okay, but PVC no. And you can see, you saw the picture there where PVC just you know was changing here. And your second question is
about why don't you use the plant phytoremediation?
Yeah.
In that project, part of the special, when you show us there is a part which is empty, you didn't use it for nothing. Can you plant, which is the red plant, Pharagmitis installalis, to remediate the wastewater? Part of that project?
Yes, you can. Actually, if you saw also, we had part of the part of those ponds which were used as emergency, but this is for emergency situation. But the plant has enough redundancy and has enough like standby equipment that you can run everything through the plant without really doing any pre-treatment or any other, things like that. So.
Thank you and good luck.
Sorry, do you have any more questions? Oh, come on, you can't be that shy.
Justin Dunning from Chelsea Technologies Group. I have a question for Ahmed regarding the system he put together there, which was driven by. Can you hear me? Yeah. Yeah. Okay. The system that was driven by legislation, you said, in Saudi Arabia. Was the actual particular waste treatment work, was that atypical, or will these requirements have to be rolled out on other similar wastewater treatment plants in the future?
I want to hear your question much better, but let me tell you what I understood. If there is any typical treatment system that can be used,
was that scenario which you presented on that specific waste treatment work? Was that not a typical one, or will there be others that will need this tertiary treatment introduced?
Yes. In fact, it is not atypical. I will not say this is real typical. And if you ask me again, I will think maybe 100 times before that. Okay. There are many other processes which is successful. Okay, and you can use. So MBR is not the only one. Actually, MBR one of the best, one of the good things. There's no problem. But also, you can actually such a plant. We had a conventional one. You can have another a bioreactor. You can have continuous backwash filters. You can still produce tertiary quality water with a different process. So it's not the only process. I would say it's not. I would not consider it as really typical. No.
Thank you.